Welcome back. Now that we have successfully grabbed our canvas and controlled it with JavaScript, let's start manipulating the canvas through keyboard interaction. This is our first step toward creating a user interface and potentially games. Let's take a look at what we need to do next. Now notice that we're not going to modify the index.html at all. We're only modifying our JavaScript here. Once again, we grab our canvas and we get our context, but we also add this new thing called add event listener. What we're going to do is capture every key down event, and we're going to call our method, which is handle key down. I've got a little global variable here, I, which is going to keep track of where we're drawing our squares. I call handle key down once to prime the entire project. And then within the key down function, every time a key is pressed, this key down function is called. And I do pretty much what we did last time, which is that I draw a green square with a black border, and then I increment the I variable by 10. And basically what's happening is that every time I hit a keystroke, it's going to draw the next square. Okay, there's our square. And now I'm going to hit the space bar. And you can see that it's drawn the second square. And I'll hit the space bar again. In fact, I can hit any key, including the shift key and the tab and control. Every time I hit a key, no matter what it is, it's going to call that function and draw that square. This is a very simple way of manipulating the canvas by way of the keyboard. Now, it's handy to just catch a keystroke and do some operation, but what we really want to be able to do is only do operations on particular keys. Let's do that next. We're going to capture individual keys. So the big idea here is that we want to draw a different rectangle every time we hit a keystroke, but we also want to change its color. And what I'm going to be doing is capturing the ROYGBIV, Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. And whenever I grab one of these keys, I'm going to set the variable color to that corresponding key. So if it's an R, it's going to be setting the color to red. If I hit the O key, it'll set it to orange, and so on. And then it'll draw our rectangle as it did before with a black border, and then it'll increment the I variables. We should have the exact same experience as last time, but instead of drawing green squares across the screen, we're now going to be drawing any color that we choose. Let's take a look at that. Okay, we start out with a black square. I hit R. Now it's moved down and to the right a little bit, and it drew a red square. Now I'm going to draw orange, hit the O key, and then yellow with the Y key, and then green, B, I, V. Okay. If I hit the space bar now, notice that it draws a violet box again. And the reason is that these conditionals here are checking the event.key, which is the keystroke that is coming in from this event. Every time I hit a key, it calls this method and it gives us an event. And inside of this event are a whole bunch of things like the time at which this happened, the XY coordinate that the event happened on, if it was a mouse event, the keystroke, any meta keys, say the shift key or the control key or what have you. We can sense which key has been pressed by getting event.key. And then if it's an R, right, we change it to red. But what happens if none of these conditionals match? What if I hit the space key? The value that comes back is going to be the word space, and then none of these will match. It will set the fill style to the color of the last time this method ran. And when we first started, the color was black. Then I ran through all these colors and I hit the V key and it ended up on violet. And then when I hit the space key, it was still violet because we hadn't triggered any of these conditionals, and then it didn't change the fill style. Now, the other thing I want to share with you, I don't know if you noticed, but down here in the console, I was dumping out all of these keystrokes. This is also something that's pretty handy, is to use console log to print out the variable of the key that's coming in on the console. If, for example, what I wanted to do was I wanted to capture, say, the shift key. What would that be? Let's go up here and hit the shift key. And you can see it's the word shift. How about up arrow? See, arrow up, down, left, and right. What's significant here is that it doesn't matter what key we hit, we're going to get some sort of indication of what that key is. Now I'm going to hold on the shift key and hit A, and we get an uppercase A. So it's actually, these are what are called raw key events, but it's also cooking them so that if I hit shift R, right, it's an uppercase R. And notice that when I hit that shift R, it did not change the color of the rectangle because it's an uppercase R and not a lowercase r, and our comparison was for a lowercase r. Let's go back. This kind of concludes our keyboard input. While it's fun to control the color of our squares, what might be even more fun is to move these squares around the screen. And as we saw before, if I hit the up arrow key inside, now remember, that's another thing to notice is that focus, if you will, must be in the context of the canvas if you want those keys to go to the canvas. If I'm down here in the console and hit the up arrow key, the console gets the up arrow key and it doesn't have the effect that we want. We have to make sure to go up and click in the browser and then hit the up arrow key to get the keystrokes that we want. And as you can see, the words arrow up, arrow left, and arrow down are returned whenever we hit those keys. In this next experiment, what we're going to do is capture the up, down, left, and right keys and then move that square around. All right, here we are. This is basically the same code as before. As you can see, we have all the key captures that will change the color of the square. We're still calling handle key down, but we've also, instead of the variable I, we now have an X and Y variable. These are going to be manipulated by the arrow up and arrow down keys. If the key is an arrow up, we're going to add -10 to Y, which means that the square is going to go up. Remember that up would be smaller Y values, and at the top of our square, or at the top of the canvas, are 0, and the numbers getting larger, move it further down. When we hit the down arrow, we want to increment Y by 10. And if we go to the left, likewise, we move in the negative direction, -10. And to go to the right, we increment X by 10. We add 10 to it. This is the exact same code we had before, except instead of printing at the I value and constantly increasing I by 10, what we're now doing is printing at the X and Y location of these two X and Y variables. And then the arrow up, down, left, and right are going to manipulate the X and Y variables, which gives the illusion that we're painting rectangles on the screen. We start off with our black rectangle. Notice that this time when I hit R, and I'll do this with orange and yellow, green, blue, it's not moving our square, right? Because we're not manipulating the X and Y variables when we hit the R, O, Y, G, B, I, V buttons. I'm going to hit the V for violet. Now I'm going to hit the down arrow. Watch what happens. Move down 10 pixels. You can see the old square up above, and it moved down 10 pixels and it drew a new one. I'm going to change its color to red, and I'm going to move it to the right. Okay, hit the right arrow and it moves it to the right. And now I'm going to do a succession of down and right, up and left. Now we've actually accomplished animation to a certain degree. But the problem we're having now, we change it to green, move it around, is it's not erasing the old square. It's moving around, but it's not giving us the illusion that we're actually doing animation because the old image is still behind it. It's a cool effect that we've got this sort of snake trail behind us, but that's not really the kind of animation that we're looking for. In the next experiment, what we're going to do is we're going to clear the canvas every time we draw and then redraw our image. This is the exact same program as last time, except that I've added one new command, which is the clear rect command. And it starts at location 00, and it goes for canvas.width and canvas.height. It's going to draw starting at 00 through the canvas width to the canvas height. It's going to reset all these pixels back to white. And then it's going to draw our rectangle again at the new location, whatever location the X and Y coordinates are. Imagine what this is doing now. This is every keystroke, it erases the canvas back to white pixels, then draws a new rectangle on top of it and in the new location. It gives the appearance that we are moving the rectangle around. Let's take a look at that. Let's refresh this. There's our black rectangle. I'm going to change it to red. And now I'm going to hit the down arrow key. And just like it did last time, it moved it down 10 pixels. But just before it did that, it erased the other rectangle. Now it appears to have moved down. And I'll move it to the right, same thing. This is not quite as impressive as when, like, now I'm moving it pretty rapidly. In fact, if I hold the key down, and now we have the illusion of motion or animation, right? This is the very basic element of practically every video game, which is that every frame you erase the playfield and then draw all your objects and then display the playfield to the user. User interfaces as complex as, say, Windows, or you can create video games as complex as, say, the old style Mario games or Donkey Kong or any of those games. And it's all based on these very simple concepts of drawing your objects on the screen and then taking some user input and then erasing the screen and drawing all the objects all over again. While this was all fun, keyboard input can be slow and cumbersome. The next set of experiments will work with mouse movements and doing animation with the mouse. So tune in for that.